Okay, so here's one for you just to kind of play with and see if you're able to kind of process everything that we just did with accessing and changing the matrices. So given these prompts, kind of see how far you can get along. This should, in theory, be stuff that you can do based on all the videos we've had so far, but just a good little experiment. So pause the video so you can look at this and then see what you can come up with. So we'll pretend you did that and go back to inline. Okay, that was fun. Okay, so if you got stuck somewhere, if you're like, wait, I didn't pause it yet, this is now the time to do that. Because I'm going to start typing. So A is equal to 12, 17, 3, and 6. B is equal to 5, 8, 3, 1, 2, 3, and 2, 4, 6. I couldn't come up with a clever way to do that. I'm going to unsuppress these just long enough to make sure that they're right. Let's see. 12, 17, 3, 6. That one looks good. 5, 8, 3, 1, 2, 3, 2, 4, 6. That one looks good. And that dude in a line. Beautiful. Okay, so these are all ready to go. All right, so if we want to get the average of all of the columns of matrix B. Okay, so remember that MATLAB, by nature, does things in columns. But the word is an average. If I try to do average, it's going to freak out and be like, average doesn't mean anything, or it's something, something, something. So really, we're not looking for the average, we're looking for the mean. So it's going to give me the average or the mean, and those look pretty right, yeah, because what's 9 plus, that's 12 divided by 3 is 4. Yay, look, I can do math. Okay, so there you go. So you've got something going on good here. If I have these off to the side, does that make it any easier for you to tell what's going on? I don't think it does. I think it just takes up more space. Okay, so get the average of all the columns of B. Okay, so then this one, we need the average of all the rows. So remember, anything that you can do by columns, you can do by rows just by taking the transpose. And I usually stick the transpose out there again because that way it's giving me them kind of in the order of where the rows would look. So 5, 8, 3 has a average of 5.3, 1, 2, 3 has an average of 2. So I kind of think of it as going like, you know, in order this direction. And then 2, 4, 6 has an average of 4. So if I don't put that extra transpose there, it still gives me the answers in order. I just personally like seeing them like that because then I can tell, for some reason in my brain, it makes sense that these go with the rows because I'm seeing the individual rows for that. Anyway. Now if I want the average of just the third column, so this is kind of combining a couple things. Blah stuff. So again, I'm getting the average of the third column. Now we didn't actually say this, but if we're doing the third column, that means we're doing all the rows. So all the rows, the third column, of matrix B. So the mean of B, all rows, third column. And that should just be the 4, right? Yeah, that's this dude right here. Okay, and now if we're just doing the third row, we're doing the average of B, just the third row, all the columns. Okay, so do you see how we're doing this? Just the third row, all the columns, and then that gives us the 4 that we got last time. Okay, so then let's see. Create a matrix says the first 3 values in A is the first row, and all the values of B is the second through the 4th row. Okay, I have to go look at what these are. I'll pull these back down. Create a matrix that has the first 3 values in A, so A 1 through 3 as the first row, and then go to the next row and put in B. First 3 values of A and then B. Done. Done, 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 done. All right. Create a matrix that has the values in, I'm just making up words, that has the values in matrix C as the first column. Okay, so column 1 is C. The values in 2, 3, and 4 are matrix B, so then the next thing is B. And then the values in A is the last row in A. So look, let me just kind of see what this gets me. Okay, this is getting me the values in C is the first column, B, tube is 2, 3, and 4. And then when A is the last row, so that's actually just 12 through 6. It's already size 4, it needs to be size 4. So oops, I can come in here and I'll say, okay, so then go A, new row, and put in A, and it fits in real nice and pretty. So that's pretty cool. So there we go. Convert matrix to a column B vector for funsies. Remember, we can just do that. Throws everything in there as a single column. Get the values of B along the diagonal and make it the second column of C. All right, I'm going to pull these down here again to remember what I'm doing. Okay, get the values in B along the diagonal. So, whatever, I can't think of a stupid word. Gum. All right, the values of B along the diagonal. So with the diagonal of B, and I want to make it the second column of C. So I want C, all rows, new column to equal gum. Look at that. There's other ways to do that. So I'm going to do it. So this is one way to do it. You could also put it in here as all rows, second column, like that. I just used the end +1 because I thought that'd be kind of cool. You could also, instead of typing in gum and doing it separately, you could do it like that, just to save yourself an extra line. But again, you're not getting charged per line of code. Sometimes you get to charge money for how many lines of code you write, so there's no reason not to make it clear about what's going on. Okay, so we got that. Find the other diagonal of matrix B, then make it the third column of C. So more gum. Oh, so we did this last time in another video. We flipped, well, we took the diagonal of the flip LR of B, and that should give me 3, 2, 2, please. Yay! Okay, and now I want to make that the third column of C. So C, all rows, and again, either 3, or you could do end +1, and that would be okay too. Kind of cool? Okay, so you're kind of getting there. And these all seem like really silly little exercises to do, but this is kind of like just getting comfortable with manipulating matrices whenever you want to do like real things with them. When you're doing actual data analysis, then this ideally should come more naturally by that.